let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed.
Hi, and welcome to another episode of In the Clouds. I'm your host, Stu Miniman. It's October 23rd, spooky season. They're doing some pumpkin decorating down the hall for me in the Boston office as we speak. Those of us in the tech industry, it's Q4, which is always a busy time. Quick note, KubeCon, Cloud Native Con in Atlanta is in just a couple of weeks. Hopefully you caught the preview that I did with Randy Bias. If not, check out the YouTube link. And we're going to throw in the chat, we will throw the link for all of the Red Hat activity that's happening on that. Really good event. Check out OpenShift Commons, of course. We've got lots of customers that are speaking on it. We're going to have a preview that we're doing with theCUBE, so look for that next week. I'll actually be making an appearance with my old crew of theCUBE on that also. But today, we're going to do something we do pretty regularly, 3 times a year. We're going to be talking very much about OpenShift. Of course, I'm part of the OpenShift team, and I love to dig in with one of the product managers. So, they've got the technical expertise on everything we have. So OpenShift 4.20, crazy to think, the 20th release of OpenShift 4 that we've got. And joining me for this episode, happy to welcome to the program, Marc Curry. He's a distinguished product manager in the same business unit as me. Marc is down in the tower, which is our official headquarters, but I'm sitting here in Boston, which is our global briefing center, and have a few more of our executives here in the office right now than he has down there probably. But Marc, great to have the Raleigh-Boston connection. Thanks so much for joining me.
Thanks a lot, Stu. Happy to be here, and thank you for the invite.
All right, Marc, before we get into the OpenShift stuff, we've had a number of what we call the boomerangs from Red Hat on here. Folks like Brian Stevens, I had met when he was CTO, and then of course he came back through the Neuromagic acquisition. I actually interviewed him on the program about 6 months before we brought him back as a Red Hatter. You're a networking guy, so maybe I say you've got multiple round trips to complete your time with Red Hat, like your TCP in effect. But could you just give us a little bit about your background, what you've done both at Red Hat and outside?
Yeah, sure. I'll try to be brief. Basically, I went to graduate school for essentially science, did a lot of computational physics in graduate school, and had to get pretty effective at it if I was ever going to finish my thesis work. And pretty soon I started helping other people take their physics problems and turn it into something they run on these supercomputers. And the next thing I know, I got hired at Red Hat to help others do that and teach them how to do it. If you've ever, in the old days, I used to do write and deliver like the Red Hat certified engineering and architect exams. So I apologize for anybody that's ever gone through one of those curriculums. I did go to another organization for about 7 years where I got much more in-depth networking experience, came back thankfully to Red Hat, and I've been back as a product manager. I was one of the first 4 as a product manager for OpenShift, and I've been had various teams that I've worked with over the years, but one constant has always been the networking team. So I've been very fortunate to work with a very, very bright group of individuals, and we've been able to do some very, very great things.
Yeah, Marc, I know I've had Mike Barrett and Andy Cather on the program. I know they are 2 of the first 4. Who was the other one that was made up the first 4? Is he still here?
There was 2 others. So Mike, myself, Steve Spiker, and Diogenes Rettori.
Okay, awesome. Yeah, and look, you worked at what most people would think of as the networking company. Company I worked with for much of my career, and a good partner of ours at Red Hat. But I'm excited because this program's called In the Clouds. Network has been one of the biggest discussions of cloud. I think back to the early days of cloud, and it was like, hey, how is this different from the XSP era? Do we have the security, and do we have enough network bandwidth to be able to actually function there? And of course, the cloud era has been very different from those of us that remember in the 90s, the XSP era. And AI, virtualization, networking doesn't necessarily get talked as much, but oh my God, like those like yourself that are in it is, if we don't fix the networking issues, we're not there. And here we are this week. Everybody was getting a reminder of how networking is integral to what we do. And when something goes wrong, sometimes it's not DNS, but oftentimes it is DNS, Mark. And a lot of us had systems that we couldn't access, as one of our good friends, the cloud providers, had a little bit of a DNS issue this week. So it's interesting stuff. Why don't we talk about OpenShift 4.20? There's some things I'm pretty excited about, but at a high level, from your standpoint, what are some of the key highlights in the areas that you've been involved?
Yeah, so let me preface before I talk about the 420 items by talking a little bit about how the industry has really changed. I think this is really, really important to understand first. And it kind of explains why we're doing the things that we're doing, especially in the 420 release. So the network industry, obviously in the past 10 years has changed a lot, especially with Kubernetes. And by that, I don't mean just lots of new small features and expanded APIs, though that's definitely true. That's definitely been happening. I mean, companies have been using Kubernetes networking for a long time. They've become subject matter experts. And they're now looking for next level capabilities that are on par with or better than what they've been using in their data center possibly for decades, right? So they're the people that are coming to us from, it used to be from telco organizations, now from financial organizations. They're people for whom their profession is the networking for their global organization. So what they're looking for is bigger things for us. I mean, sure, we could go ahead and continue to do a lot of the smaller features and API surface and increasing of scope and so on. But what they really are looking for is that 600-pound gorilla in the open source space to take on a leadership position and say, this is what people really need, not what they're used to, not what they were told they have to adapt to. This is what they want. Let's give it to them. And these are things that don't happen even in a single minor release of OpenShift. These are things that are multiple teams working potentially across multiple releases to deliver something that's absolutely essential to these organizations around the world. I mean, it's no longer a conversation about the networking really, so much about a particular cluster. It's about all my clusters. I might have 10,000 clusters. And how is it that I can integrate that, in an enterprise way into my global architecture? And so with that as sort of the backdrop, this might help kind of explain what we did with some of the things in 420. So the first and probably the biggest networking feature that we released in the 420 timeframe is BGP full support. BGP has been around for a very long time, but in Kubernetes, it's been a bit of a it's just simply been implemented either in a lackluster way, or it just simply hasn't been implemented at all. But this is something that's absolutely critical to these organizations. And so building onto some of our other previous features that we've created, we added this. This is really our second major feature to come out of something that we're referring to as universal connectivity. Universal connectivity is that effort that is focused on those really big major networking requests. The first one was user-defined networks, which we released back in 4.18. But we finally got up to a place where BGP is now fully supported in our default networking. So that's probably the biggest and most major of the features that we did. I'm happy to talk about that some more. Another one was
Mark, let's stop and drill in for a second.
Sure.
So actually, since we didn't have a networking person on when we did 4.18, we have had some of our virtualization people come in and mention it briefly. But since I've got the networking pro on here, I'd love for you to just explain. I've talked to plenty of our customers and partners that were looking at like, hey, I want to bring my virtualization environment. KubeVirt's been around for a lot of years, but we had one of those roadblocks, and it wasn't until we had UDN to really open up that multi-tenancy and networking that they could now go forward. So
Yes.
can you explain why 5 years after having KubeVirt in, we finally have UDN, and what the before and after looks like?
Yeah, so here's a funny story. I mean, well, funny, not funny. We, like I said, if I wanted to, we could just spend 100% of our time on these smaller features and API changes that every company in the world wants. 100% of our time, we could do that, and we probably would never get to all of them. So we had to, the tough job, one of the tough jobs of a product manager is to say, look, that's not what's going to make, and it's not going to be a leadership thing in the industry. That's not what customers really ultimately want. That's not getting ahead of the problem. So what we started to do with universal connectivity was to try to get ahead of the problem, get ahead of these requests, and start to develop these things. And so when a lot of customers got to the point where they said, hey, we're going to move our entire workloads over, virtual machine workloads over to OpenShift virtualization, we were already at least 9 months into the effort. So we got a real running start on it. And so we were able to deliver upon some of these requirements really quickly. And so this is part of the benefit of taking on this sort of leadership position on these things. So what's an example of how somebody might use this? Maybe it's best explained by giving you a real world example. We have there are companies that have, let's say 100,000 virtual machines, and they want to move these 100,000 virtual machines from their traditional virtualization platform to OpenShift virtualization. And they're saying a few things. They're saying, first of all, look, if I'm making the change, I don't want to be doing things the way everybody just sort of expected them to be done in the past, sort of this lazy way. We want to take advantage of modern networking, and we want to have that to be available at this new platform when we get there. The other thing too is they're saying, look, I don't want to, please tell me I don't have to re-IP all of my 100,000 VMs and my gateways and everything else. Excuse me. And so they're saying, I want to be able to, when I get to this other virtualization platform, I want to be able to have a network very similar to, and all the network segments and the security and all the things very similar to what I had before, but I want to take advantage of new things. So, for example, I've always wanted to be able to do layer 3 live migrations of my virtual machines instead of being restricted to layer 2. So what we did was we set out to not create the networking environment they had before, but to create a modern networking environment that was really what they wanted. So to make it as attractive to move to as possible, and to make it easy to move to as possible. So with user-defined networks, how does that play into this picture? You could pre-create the network segments on the destination platforms and mimic them exactly after what you had in your previous virtualization platform environment. You could configure, all the things, the security, the microsegmentation, the storage sharing, all the other things ahead of time. And then we have tooling, MTV, the Migration Toolkit for Virtualization, that will help you take all of that workload and move it either all at once or piecemeal. In the case of something really huge like 100,000 VMs, move that over to this new infrastructure, and you have an absolute minimum of downtime. You just keep running. You don't have to say, oh man, I forgot about that thing, which was expecting it to be at the following IP address or network segment or whatever. It's simply still there. Now, how do you get to these things? Like if you start to spread out your workload across different data center environments, what if you wanted to say, well, I don't want to just stay bare metal on-premises platforms. I want to start to take advantage of cloud instances. You need a way to figure out where that stuff is. And that's where BGP comes into play. So BGP essentially is this great way to advertise routes to all the network segments and the objects, the VMs, the pods that you have in those network segments. So BGP support is really huge, and it has some other advantages, things like being able to establish multiple routes to the same VM, for example. And then, we support BFD, so we have fast failover in the event that one of those links, or if a node goes down, or if you just manually live migrated a virtual machine to another platform or another node. And in fact, where we're going, Stu, is this is not even just about a cluster. This is about multiple clusters. So we want to be able to take these network segments and we want to spread them out across multiple clusters. And we've already got management tools in place to work with those, ACM, ACS, and so on. But we just wanted to, maybe the best way to say it is, look, it's just networking. Why are we telling customers you have to adopt to the way Kubernetes does networking? What they want us to say to them, and what we're doing is saying, this is just standards-based networking that we're adding to Kubernetes so that you can take advantage of it using all the things you've been using for a long time in your data center.
Awesome.
I'll pause there.
Marc, glad, yeah. So when you talk about multi-cluster, that was one of the big themes I saw when we look at both our AI offering of OpenShift as well as Lightspeed. And in case some of our audience don't know, OpenShift Lightspeed is a virtual assistant. We launched it, it went generally available, I believe it was in 4.19, but it can help access all the documentation. You can do troubleshooting. It's a natural language way to interact with your environment. And what we get in 4.20 is it's now multi-cluster. So Marc, I'm sure a lot of you just teed up multi-cluster. How does AI and the Lightspeed stuff, where does networking tie in for those sort of activities?
Yeah, great question. So as you said, in 4.20, we released Lightspeed 1.1. And that adds multi-cluster support. So you can scale your operations. And in simple terms, what is Lightspeed? It's just simply a built-in AI assistant for OpenShift. So it lives there right inside your web console. You can ask it plain, English or whatever your language is, questions. How do I deploy this operator? Why is my pod failing, etc. You can ask it these questions and it'll come back just like any other AI assistant that you've hopefully been using, to give you informative information to explain what's going on. Today, it's generally about, tell me about this, but where it's moving is, I would like you to modify this. And so you may not even need to know how to configure something. You can say, just simply, can you add this new thing? Or can you, configure a certain way? Or can you connect to another cluster? That's where it's going. So there's questions today, there's actions to quote unquote tomorrow. And with something like networking, that's super important. So, and let me explain. So there's two things we're doing from a networking perspective with regard to AI. First of all, we're enabling AI workloads. So there's a lot of aspects of AI that is impacted by networking. For example, what if you wanted to limit the number of questions coming in on a particular AI instance? What if you wanted to filter those particular things? What if you wanted to redirect similar requests to a separate instance of LLMD that or the large language model that has been caching up some of those questions already? So there's a lot of things like that where networking comes in to enable AI workloads. But also, on the other part of that is AI helping networking. So networking is hard. I'll be the first one to admit it to you. It can get really convoluted at anything other than a very trivial deployment of a platform. So don't fight it. I guess is what I'm saying. AI is there to help, and it actually can provide a huge amount of help on these things to help you understand what's going on. And so Lightspeed gives you that very custom experience specific to OpenShift to improve your overall administrative developer experience with one or more clusters.
I'm glad, Marc, you mentioned LLMD, and it's been really interesting to watch because we have a certain level of stability built into Kubernetes today, but the use case of generative AI is causing changes in a lot of the underlying components that we have in Kubernetes. And of course, LLMD is helping to pull those things together. So I know your team works very closely with everything that lives on top, including the AI piece. I know there's a new thing that got released in 4.20, and hoping you can explain to the audience, the Gateway API inference extension. What is it? Does that tie in with the MCP things that we're starting to hear about? When I watched the what's new in 4.20, heard a little bit about MCP. I know I've got a couple people on my team that are digging in and getting ready because there's so many changes going on in the AI space. It's tough to keep up. But yeah, why don't you talk a little bit about that?
Yeah. So I can, it gets into the weeds pretty quickly, but let me hit it at a high level. So what this gateway API inference extensions is, or GIE for short, it's an effort that builds on OpenShift Networking's Gateway API, which is our modern instance of ingress, getting traffic into the cluster. That is sort of on par with HA proxy at the moment. It is still the option. HA proxy is still our default, but so what this GIE does is it builds onto this newer, more modern form of ingress Gateway API, and it provides specialized routing and traffic management for AI/ML workloads. So, and maybe backing up a bit, so AI and machine learning workloads, they have unique challenges that make traditional load balancing strategies, like, for example, round robining across elements, a poor fit. So our Red Hat OpenShift AI, and especially version 3.0, the brand new version, addresses this challenge with distributed inference with LLMD. And that's based on the Kubernetes API inference extensions. And so what those inference extensions are is just simply literally extensions to say, don't treat this ingress just like ordinary bits coming into the cluster. I need to do some deeper, potentially deeper inspection and filtering of those elements as they come in, as it pertains to AI. Like, for example, maybe I want to associate an AI session of somebody who's asked a question before with a previous session to follow on to their question. Maybe like I said before, maybe I want a rate limit. Maybe I want to avoid bad actors. So there's all kinds of things that you want to do to protect your AI instance. And in fact, where we're going is there's something called MCP, which is the I won't get too ahead of myself here, but basically MCP is this the acronym just slipped my mind.
It's Model Context Protocol.
Model Context Protocol. Thank you very much.
It's all right. I love the shortest analogy I've heard for it is it's hoping to be the USB for how my models can attach to other other resources out there. So
yeah, that's interesting. It's really just simply going to be a server, an MCP server extension for Kubernetes and OpenShift. And it's an open standard that enables AI systems, LLMs, to securely and consistently connect with external data and tools and services via this unified interface. And the MCP server is the thing that takes care of that. MCP gateway is once again this thing that lives at the edge to say, no, let's protect that MCP server because it has the possibility to leak information, do dangerous things. So let's filter it and not let just any old traffic into it. So there's a lot happening there, and all of this is networking, right? I've talked about ingress, traffic coming into the AI, but there's also things that leave AI. You may want to have filters on that as well too, maybe for sensitive information, or maybe you don't want MCP to go anywhere other than a pre-approved tool for further massaging of the data.
Yeah. Sorry, please finish. Yeah, if you were.
So basically then. Like I said, so going back to the original thing about Gateway API inference extensions, so they just simply provide advanced capabilities to or for routing these inference requests that come in based upon the specific model on the back end and also available load telemetry. Like maybe we want to, one particular LMD is completely overloaded, so we want to redirect it to another instance, maybe another cluster, wherever. And so that's really what it's all about. And so again, we can certainly use AI to help understand and demystify networking, but also you need strong, secure, enterprise grade networking to enable these modern day AI workloads.
All right, Mark. One last topic I want to touch on when it comes to networking. So, we've got all these wonderful features and everything, but the network itself, it's often, performance and scale. So, I think back to, the time you mentioned supercomputers. And, I remember if you think, 20, 25 years ago, it was up, a lot of our traffic was north-south. How do I get to the internet? How do I do things? Supercomputers, virtual machines all drove a lot of east-west traffic between nodes. With today's environment, we still have virtual machines. We've got AI. I'm sure this is putting a lot of, different challenges and strains on the architecture and the networking components. So how should I be thinking in 2025 about performance and scale and networking, and what are you and your team focused on there?
Great question. There's several different angles to this. The first one maybe is simply scale. So people aren't running 5-node or 6-node clusters. They're the modern day workloads of the very big organizations in the industry. They want to run as big as they want of a cluster, and so we need to make sure that networking is not the problem. So we need to ensure that the scale is there, the performance is there. We've largely, on the networking side of the house, gotten to the point where we've exceeded what other components of OpenShift are capable of doing. So I don't want to rest on my haunches on that. However, I feel like we're in a pretty good place there. We are working with other teams to stretch that scale to something larger. It is a priority within our organization to do that. But also, it's getting into the minutia of it. Well, some of the actual protocols and so forth. One of the great things about OpenShift is, a lot of times, people forget, look, we've got a fantastic enterprise operating system in the form of Red Hat Enterprise Linux. And so I work with them on an almost daily basis to ensure that the technology that's been proven there and the newer sets of technology is supported at that underlying base. Make sure we do the hardware enablement as new hardware comes out to increase the performance of the networking, that we support it, and then very quickly, first in the operating system, and then very quickly after that, supported in OpenShift. So, and that includes protocols. I've spent a lot of time. There's don't know if you've heard about it, but the Ultra Ethernet Consortium. It's a very large multi-vendor organization whose primary goal is to take Ethernet to the next level for modern day workloads. So if you're going to be talking to any kind of a high performance computing organization and you want a seat at the table, you have to be able to say, we support that, or we will, or we're in progress on supporting it if the standard is not completely gelled at that point. So, for example, that's a good example of like some of the high performance things we're working on there. We do hardware offload. So we work with organizations, for example, DPUs, that to take the control plane parts of OpenShift, offload it to, say, a DPU, so you can free up the core of the actual server itself to do what it's supposed to do, which is some, maybe some pure horsepower to do some of these AI ML calculations, or maybe it's an HPC physics problem or whatever it might be. We have a lot of our customers are what's referred to as core challenged, meaning they just simply don't have enough cores in their platform to get things done. And they definitely don't want to, reserve cores for something like the control plane. So we have, with our hosted control planes platform, we've essentially taken it and unified a control plane across multiple, what I guess you could say are data plane only clusters, and freed it up that way as well too. So we're doing it in software, we're doing it working with the vendors, doing it in hardware. Security comes into play and all this stuff too, Stu. There's just quite a bit happening. We ultimately just don't want networking to be the problem. So once again, we're trying to stay ahead of the curve, and we're making sure that these new standards as they come out are going to be fully supported day one. We don't wait for things to GA upstream. We wait for them to get to beta. And at beta, it's generally regarded as that's the point at which the API is stabilized. So what we do is we wait for that, and then we say, okay, let's harden this thing, run it through our enterprise process, and let's support it for our biggest customers.
Yeah. Well, Mark, we could definitely go for a couple more days on this. I love what you're just saying. You don't want networking to be the problem, even though one of my truisms I used to say when it comes to networking, there's no such thing as eliminating a bottleneck because you've just moved it somewhere else.
That is true.
So before we let you go, we need to have you answer a few questions from a Red Hat.
Okay.
All right, Mark. First one, our audience might know what my first question is because this year I think I've used it with every single guest. But we want to talk about AI, and not about from a networking standpoint, but how are you, Mark, using AI in your daily life?
That's a great question. Well, first of all, I will tell you, I use it on a daily basis. I think you know, if you aren't, you're doing yourself a disservice. AI is getting exponentially better. So what exactly do I use it for? I would say probably the most common thing is to help me break down an otherwise very complex topic into simple pieces, and use that as a starting point to build out, you know, first principles for how it is that we can offer this, you know, and how it might be useful to the industry in general. You know, I love using something which is, you know, hey, in simple terms. I always start with that. In simple terms, tell me about this, or give me 10 bullet points that describe something in particular. And it's a really, you know, that's not going to answer my questions, and that's not going to get me very far, but it's a great starting point. And so that, I think, is probably the number one use of AI today. I would say the second, probably most popular use I have for it is, it can be, you know, I think documentation is our documentation is excellent. But as long as you're using an AI like Lightspeed that's focused on supported and proved out documentation, for example, for OpenShift, I love it for reasons of saying, remind me again how it is that this works, or remind me again about if I'm going to install this, what step did I forget to do? And so in that case, you know, it saves me just, you know, 30 minutes here, 30 minutes there. And after, you know, a few days of that, it all adds up. And so it's a really big help to speed up what it is that I'm ultimately trying to do, which is do something with that particular feature that's useful or constructive for the industry.
All right. Speaking of speed up, Mark, this question of you as a networking pro, you know, I think back, you know, you probably remember, you know, when 1 gig was, you know, a little bit futuristic, and we rolling that out.
A little earlier than that, Stu.
I mean, I don't want to go back to how early we think about this, Mark, but, you know, I remember it's like, oh my God, you know, the interfaces and the cabling and the distance, and like, there's so many different layers on that. You know, I try to stay up at layer 8 and 9 when I'm meeting with customers, because everything else at the CIO level, that's a networking problem. But wonder if you can help us put into context a little bit, you know, talking about even, you know, 1 gig and before today, you know, 200, 400 gig bandwidth, and heck, you know, terabit is, you know, been being discussed for a number of years. You talked about some of the things. Help us put into context, what is the impact now that we have, you know, almost limitless bandwidth in networking?
I know of several industry segments that might challenge that assumption, that we do have, you know, basically unlimited bandwidth. However, I think for most users, you know, when you have a 400 gig NIC, you're probably not using 400 gig NIC. So what that allows you to do is maybe, you know, the people that write the applications can focus more on what the application is trying to do and less on network optimization of their particular application. So it frees them up. I don't want this to mean they're being lazy. That's not the case. They're prioritizing what it is they do. They're prioritizing function and capability over the optimization. They may come back later and optimize the networking bandwidth, but in a lot of cases, it's just freed them up from that. They don't have to think about that quite so much anymore. We absolutely have organizations in the industry that just simply can't get enough bandwidth, and these like the large national labs and some other organizations. But I think that's definitely the exception rather than the norm.
Yeah, Mark, I think that's really astute. I remember talking to people earlier in my career, and as a networking person, it was like, oh, I built the architecture of the application based on the limitations of my infrastructure, and now I shouldn't need to do that. Yeah, you're totally right.
Yeah.
The top 100 supercomputers are a little bit outside the norm versus what your general enterprise has. Okay.
Yeah, I remember one time, just as an example, I remember one time I actually did the networking for, believe it or not, for State Highway Patrol. Their radios in their cars, they had to bounce from tower to tower if they're going after a bad guy, 100 miles an hour. They were bouncing tower to tower, and I had to plan my data to give to the officer in the car around. I couldn't assume anything more than in the range of kilobits. So because of that rapid bouncing and the old technology back then. So that definitely was my primary factor when I was trying to deliver, for example, a photograph of the suspect or something like that to the officer's computer in his car. But thankfully, I think we've gotten beyond that nowadays.
All right. Last question, Mark, with your product management hat on. We've talked about how fast things are changing. What's the biggest challenge of being a product manager in today's technology landscape?
Wow, just keeping up on it all. It's definitely a challenge, and I am only successful because I work with really awesome folks. I have a brilliant set of engineers. I have a networking director, engineering director that I work with that shares a common vision of where we need to be. And I have other product managers that I work with that help, because many of the large scale grand challenge kind of problems nowadays, they're not just a single team. They're not just networking. I have to maybe build something into the user interface. I have to work with the observability team. I have to work with whomever. And so having a really good team of people to work with is absolutely essential. One of the things I value most about Red Hat is the transparency in the organization. And it's because of that we're able to share ideas, and everybody is welcome to contribute into the end goals. And I think as a result, we end up with something much, much stronger in the end. But I will tell you that it's probably the biggest challenge. It's just simply the speed at which things are changing and growing, and it's challenging for anybody to say, I know networking. There's just too much there.
Yeah. Awesome, Mark. Well, thank you. You've completed the gauntlet of the 3 questions from a Red Hat. And I'm so glad. I want to give you the final word. As I said, my background, I did storage networking. I was an analyst and covered the networks. I've known some really, really bright networking people that joined Red Hat, that are part of Red Hat. Red Hat's not one of the first companies you think of with networking, but Red Hat absolutely has had some major impact as to how networking, and not just with Linux or with containers, but the industry as a whole. Any final things as to where people, if they want to learn a little bit more about networking from Red Hat or the like, where they should go?
We've got OpenShift networking training that's in the works right now. I hope to have some good news about that maybe in the new year. So there's more to come there. I would say, Lightspeed AI is going to be your friend. I will say that, if there was ever a question about us being a networking organization, I think Chris Wright, our CTO, put that to rest almost 10 years ago. I remember being in a meeting with him where we challenged him with exactly that question. Are we going to focus on networking? And he very quickly and succinctly threw the gauntlet down and said, we are a networking organization. And we challenged him on that, and he has supported us the whole way. And as a result, we've become an industry leader in that regard. So, and we're sort of setting the pace for a number of very advanced features and capabilities with regard to Kubernetes networking So I think we've been very lucky in that regard.
All right. Marc Curry, you got any good networking jokes to close us out on?
Because of some of the recent stuff that happened, I can't help but just immediately pop into my mind. I apologize, but there's that haiku meme that's floating around, which is, it's not DNS, it can't be DNS, it was DNS. I think I'll spare you any other bad jokes, but that's the one that pops into my head first.
All right. Well, Marc, pleasure talking to you. Thanks so much for sharing a little bit, just dipping our toe into the broad spectrum of network topics. It's been a pleasure.
Great. Thanks, Stu.
All right. And thank you, everyone, for joining. Definitely, we'll have a couple more episodes before the year is done. Be sure to check out the back catalog. If you have any thoughts on topics and guests that we should have on, please feel free to reach out. And I will be at KubeCon Atlanta, as I mentioned at the top of the show. If you're there, definitely stop by the Red Hat booth and reach out if we can connect there. And always, thank you for joining us on your journey in the clouds.